All right, folks, I have some lecture slides on the setup of Android, but I really thought I'd walk you through Hello World from what's called soup to nuts, beginning to end, by going straight to, I'm on a computer where I need to download Android Studio. So I'm going to walk you through the entire process, do a Hello World, and then that'll lead us into our hybrid application development. So I'm on the Android download page. It's at developerandroid.com/studio. And it recognizes your type of device. I'm on a Windows one, so it's telling me download for Android Studio. So I'm going to start that process, all that stuff, and now it's going to start downloading. And as it does, I'm going to pause because you don't want to sit here and wait for it to download. And when I come back, we'll walk through the installation. All right, my Android Studio is downloaded. I'm going to start the installation process. Again, a lot of fun while its setup is loading. The Android Studio, it used to be an Eclipse extension. Now it's based on IntelliJ. Um, so some of the things, if you're used to doing Eclipse in your classes or something else, are a bit different. Number of things I'll ask you to install, and this is part of what I want to walk you through, is there's a whole set of different API level support that you can be built in. While this is going, the way Android tools are set up and Android Studio is set up, Android has its own set of tools. And those tools can be run from the command line, and they get installed with Android Studio. But Android Studio, when it does a number of its things like spawn a virtual device, use the debugger, even the SDK installation, that's actually installed on your system distinct from the IDE. The IDE points to it, if you will. So the IDE, when it invokes a number of functions from its menus, like I'll do after we're set up, it's actually doing that by spawning a process out of the IDE. So it's what I'm trying to say is the tool chain is not entirely fully integrated, if you will. And you have to be aware of that because, first of all, there's some things you could always do from the command line that you don't need Android Studio for, because Android Studio, big memory hog of an IDE, can be slow if you're on an older system, kind of thing, and you could do some things from the command line. But the second is it'll also help you understand why sometimes the integration is not all that clean. The tool chain, what I'm trying to say, in Android Studio to me is not nearly as good, let's say, as the Xcode based tool chain for the iOS platform. And so trying to get a stable studio set up, understand where your tools are, and get that working. This is something you need to spend time on. All right, I'm spending time to walk you through this here. But, don't just the night before your last lab is due, decide you're going to go out and install all this stuff and get it cleanly working. You need to go out, run some sample programs, do the Hello World that I'm going to walk you through, and make sure that your environment is stable, can build against target APIs. If you have an Android device that you're going to run live on as opposed to an emulator, you want to make sure you have that connected, the device is recognized in the development environment, you support the API level, and all this kind of stuff I'm going to walk you through. So this is worth the investment of your time to go through that. It's going to take a little while to do the extracting, so again, I'm going to pause for a second and come back when it's ready to go. Okay, I'm back. That was actually about a 20-minute pause just to get everything downloaded and installed. But I'm going to start up Android Studio for the first time. We're not going to import anything, so we're just going to do a fresh install here. Not sure why I still had the setup wizard in there twice. I'm going to cancel that. All right. Standard or custom. We're going to walk through custom just to see what the set of things are. So you have different themes that you can do, the IntelliJ or what's called the Darkula. I actually use Darkula on my laptop, but we'll stick with the standard install for here. Now, what it's asking for next is the SDK. Remember, I just said that the SDK was separate. Now it's saying it was an existing Android SDK detected. So it's going to use that, so it'll find one if you already had one on your system. It's asking if we want the new Nougat and so forth. So why don't we get the very latest and greatest while we're at it, and the virtual devices. And again, I'm going to talk about the virtual devices when we bring it up. I'm going to download all these things, and my guess this is going to take a while. So you know, 1.5 gig here, so I'm going to pause again while these components are getting downloaded. All right, I'm back. So finished that part, and I get the welcome screen of Android Studio. Before we go do a project, let's take a look at the configuration of various parts, in particular the SDK manager I was talking about. During install, by default, Android install the latest version support. This is the SDK, the Software Development Kit's latest support for the latest version of Android, which just came out, 7.0 Nougat. If you want to support other versions, then you have to select them. What I'm selecting are the versions down to KitKat. Those are the versions that the APIs that are relevant to us are going to be useful for. I didn't select the KitKat where, but I'm selecting the different versions of the APIs from 19 through 25, except version 20. Also, they also have the standalone SDK manager, which you might want to look at, because that's something that you can spawn out of the Android Studio IDE directly. And this will give you a lot of deep details about the kinds of things that are installable and what's installed. Let me make this bigger. And you see so far it has already installed SDK tools and platform tools and build tools for latest version of 24 of the API and 25, like we were talking about. It has the SDK platform for 7.1.1 and for 7.0. I'm going to deselect. Well, I'm not going to bother deselecting, but when you select some of the stuff, there's support for different images and so forth, including things like sources. I guess I will deselect. I don't think you need the sources. Having the version of the documentation may help, but of course you can all get it out on the web, so I'm going to deselect that. It's actually asking me if there's certain packages I want to add and remove, you see down here. So navigating your way through the SDK manager, you know, sometimes it's non-trivial because of the way it's structured, but this detailed one will let you explicitly pick out the things that you do and do not need. I'm going to delete those two packages first. The source code again in the documentation, not the SDK itself, not the libraries itself, but I'm going to give it a second to do that. That should go pretty quick. I shouldn't need to pause here. All right, that part's done. Now let's go back and see the packages that it does want to install. So for example, it wants to install support for Android TV, no, Google APIs, I'll leave those on there. There's a fourth one on there it wants to install. I'm not exactly sure where it is. It may be all the way at the bottom, for all I know, some extras. Google USB driver. So that's the generic driver for connecting a USB device. So I'm going to leave that on there for now. Now, if you notice, it goes all the way back to API 7, all the way back near the beginning. But again, we're only going to worry about API level 19 and above. Now, it's selected all those things. I don't want all those things. I'm going to take a bunch of those things out. The Google Glass appeared then, the sources and so forth. I'm just going to select on each one of these the SDK and the Google APIs. And I'm going to do that. Let's see. I didn't need API 20. That was the Google Where. Didn't need that. So I'm going to do that. I'm going to do that. That's version 6. We already have version 7 installed, so I'm all good to go. So I'm going to install these 11 packages. That's going to take a little bit. So I'm going to pause after I start this process. Alright, so I'm all up to date on my build versions, my API version support, and my SDK, I should say. So I'm going to go ahead and start a new Android Studio project. We'll call it Hello World, because that's always the first thing we do. You could set your own domain. I'm going to set it to EDUA issue SCR 421. We don't need C++ support. We'll use the default project location, although again, just like most IDEs, you can pick your own. It asks us for the minutes. This is what it's doing is in this wizard, it's going to walk us through support for different devices, device levels. And this will write out for us our various manifest and build files that will support different versions of the API. So we'll look at how this looks in the actual files it creates, but you should always know what your targets are, if you will. And notice by default it started us with API 15, or what's known as Android 4.03, or what's also known as Ice Cream Sandwich. So one of the things about working the Android platform is you have all these version numbers flying around and version names, and you got to kind of keep them straight. I can explain to you why they did that, and how it's helpful and how it's not. Notice how sometimes, like with API 16, 17, and 18, they all map to something called Jelly Bean, 5.0 and 5.1, both to Lollipop. Don't ask me to explain it, but it can be admittedly very confusing. Again, for our intents and purposes, we're picking the minimum SDK. So basically what we're saying is we want to go back to support this version of the API and then all versions of the API going forward. And for us, that means KitKat. All right, so we're going to select KitKat to try and do that. We're not going to select any of these other ones. We're not doing Google Wear, Google TV, Google Glass, or anything like that. We're just doing phone and tablet. So I'll select next here. And then it's going to say, okay, it has a bunch of default wizards. You see this with, a lot of application builders, if you will, different things that you want to do as a starting point, different styles. While there's a number of these things, we're going to start with an empty activity. Now remember, and think about it, it's creating a new project for us, a new application, but it's asking for the entry point. Remember what we talked about last time is there's 4 app components: activities, services, broadcast receivers, and content providers. But the activity is the visible thing that somebody sees on the screen, interacts with. So it's asking what would be an activity that we would use as an entry point. Because we're building a hello world from scratch and we want to kind of build this in the IDE, not the wizard, I'm going to stick with this default empty activity. All right, it'll give it a default name. We can name it anything we want, although whatever name it's given will appear in our Android manifest as that entry point, and the layout name will appear in another configuration, a resource file as it's called, that we'll talk about as well. So right now it's using main because main is what we like to traditionally use, but I'm going to call it something different just so you can see how this has an impact on the files that are created. Notice it changed the activity and layout name together. That's just for convenience. There's nothing that says you can't call it anything you want. The layout is going to map to the layout of the screen or the layout of what's called our view, as I said before, on top of our activity. So it's just like you do a GUI layout in any GUI technology. Again, you go back to a desktop layout in Swing, you're going to have a layout manager that that manages where things go on the screen, not what the things are, but where they go on the screen. And then even in our web, we have a set of widgets in our layout of what gets put on the page is something that we artificially manipulate explicitly via the CSS, or we can use tables, or we can use div tags and so forth. So the layout kind of says where things go. Anyway, we're done. Let's finish it. Let's get Android Studio fired up here. As you can see, it's lightning fast, and Windows isn't going to like certain things about it, but I'm just going to say to heck with all that. Come on, Windows, let me. This is Windows 7 box that I'm on right now. So great. Notice how Gradle's running all these things. Gradle's is the build system here. Make sure you can see everything. I don't need to see a tip. No, I don't need to see a tip. Go away. All right. Now I got nothing. Right? It looks like a blank screen. IntelliJ, if you're not, and I'm not used to IntelliJ. I was always an Eclipse person. But if you look, there are different tabs here on the left that will impact what things you see as a pop-out. So there's the project pop-out, there's a structure pop-out, and a captures pop-out. The main one you're going to spend time in is the project pop-out. Before I go into the app itself, let me talk about Gradle again for a second. Gradle is the build system. Just like the SDK, Gradle is now Android Studio will install it, or you may already have your own installation, but Gradle is the build system, and it is distinct from the SDK, meaning I can build my application without having Android Studio installed in my system. I can build it on a continuous integration server like Travis or Jenkins by having Gradle installed. Gradle is actually the thing that spawn and does the execution. Android Studio just provides some integration so I can see the things that happen and fire off Gradle builds from within the tool. So if you notice down here on the right, I even have this little Gradle console that I can pop up. So it already did a first default build based on the auto-generated build script that it created. There's a build script. This is a build.gradle for the entire project. It'll indicate what my class path dependencies are, where things live for Gradle itself. The one for the app, and by default, the way Android's going to refer to different modules in your application. Your application only have one module, and by default it's named app. But there's a different build.gradle, and that's going to have the stuff much more specific to what you're doing. Notice in here a few things. First is I have a compile SDK version 25. The build tool version is 25. So I'm using the latest versions of all those things that I selected. It's using the latest to do the build. But for a default configuration, it's giving me a minimum SDK version of 19. Remember, I selected KitKat and above, 4.4 and above, or API level 19 and above. So I have a minimum, but then I have a target, right? That target will typically agree with these, but my minimum says what I want to support. I'm doing the first, by default, it'll give me a version code and a version name. We won't talk much about version code and version name. Those things would be important if you post something to the Google Play Store, because those are the things that you have to rev if you're doing an update per se. And all this other stuff that's in the defaults right now for the intent and purposes of what we're doing, it works for us. It is fine. Notice, however, too, is there's actually some dependencies down there already included, including unit testing support and test compilation support. And if you look in your Java directory structure for the code it actually generates a test file. All right, it's pretty empty right now, but it's already instrumented with Android extensions to JUnit 4 and a URL to explain how you would do that, as well as just a straight unit test. And notice how it gives us a very simple sample test that'll always be true, but it gives us a way to at least start off giving us stubs for generating unit tests. So always a good practice. But our code itself will reside in our main package we created in the wizard for hello activity. And right now it basically has nothing, right? Public class hello activity extends app compat activity. That was a way of providing backward support. You may not have noticed I had a checkbox that I left there by default. Generally speaking, you're going to leave that there, at least for our intents and purposes. Now, there's two things on here. First is, notice the first method. We have an activity. We are extending a built-in Android type. That's how we basically become an activity. Again, this is called app compat activity. There are additional activity types that you could extend in the Android framework. But by default, that's what you're usually going to use for an activity. And remember the state model that we talked about. So by default, it's going to add for me the listener for on create. It's not adding me the listener for anything else. On pause, on restart, anything like that. It's giving me on create. Any other ones that I want to add, I got to add on my own. It's considered best practice to call super to the app compat activity first, just like you would do if you wanted to invoke a constructor. So again, we're not creating the object here, the framework is, but it's giving us a similar call sequence or call options, construction options like what we get in a Java constructor. This bundle is, I don't know what bundles are, but it's a way of packaging information passed into an object. It's an aggregate object. And basically, if we have a saved instance state, meaning if we wrote let's say an on destroy or on pause or on stop method, and we want to save the state of the application so that when it's recreated, we come back to the same place. We have the responsibility of doing that. We can create a bundle object, save it off, and then when we go to on create again, we'll get that saved instance state. So that's why that parameter is there. All stuff that's more relevant on the native side that, again, I'm talking through it quickly because it's not necessarily going to be relevant for the hybrid apps that we want to create. But then also notice a set content view. with that, the name, you see that name, that's the name that was set in our initial layout, right? And this is the layout part. Then we have this magical thing called R, all right? Well, R is a reference to an auto-generated Java file. And it's auto-generated, so you don't even see it in here, right? You actually have to go digging for it on the file system if you want to go find the r.java. The r.java is going to be auto-generated from a set of resource files, which are XML descriptors. And that is the way that they're going to provide their responsiveness or their platform independence, is basically creating XML-based descriptive files of your UI and then turning around and displaying those. Let's run the app and then I'll go back and show you more about the resource file. All right, so it's asking. I don't have any connected devices right now. So by default, it's giving me a virtual device that it installed at the time, but we can also create a new virtual device. So let's go ahead and do that. And you get a whole bunch of options here: phones, tablets, different filters to define. Let's do a tablet. Let's create a 10-inch WXGA tablet, kind of a generic tablet with a max resolution and pixel density. Indicate what API level we want it to support. Now, if you notice, we've got some system images here, and we don't have, we haven't downloaded yet some of the AVD images for it. So let's go to Lollipop, or let's go to Marshmallow. My phone's Marshmallow. So let's do Marshmallow and download it. All right. So again, this is typical in Android. We go through all these downloads to get an environment configured, and of course that's going to make it seem a bit messier because of the variety of devices and revs of APIs that Android supports as a more open source, open platform than, say, the Apple platform, the Xcode platform. All right, we don't have tons of iPhone devices, right? We have a set of managed devices put out only by Apple, whereas Android's trying to support every knockoff brand you could possibly think of these different devices. All right, I'm going to pause again for a second and let this install. All right, that wasn't too bad. It's back, and now I can select Marshmallow if I want. And go ahead. Don't worry about the hex. The HexM part's kind of an optimization, which you can install if you want, but not too important for us. Generic name for the AVD. We're going to indicate what, are we going to start up in portrait and landscape? All these kinds of things. We're going to take all the defaults. I'm not going to worry about any of this stuff right now. We're going to click Finish and give Android Studio a minute to do what it needs to do. All right, so now we're back. Now I can select that version of the tablet. Oh, it said HexM isn't required. And again, this is not atypical of the kind of thing you go through with Android Studio the first time. And so I think it's reasonable. It's pretty good for you to see it in the video because, this is the kind of thing that happens that can be quite confusing working initially with Android Studio. Okay, well that was a quick install this time, so now I have HexM, so it should go back, and now it can't run the AVD anyway. It gave us a default name for the AVD, and Android Studio doesn't even like it, right? So this is again pretty typical, and you have to get it's good to see errors like that because you got to get used to working in Android and kind of seeing that this is the kind of thing that goes on. So I'm going to fix that by going into the AVD Manager. So I'm under Tools, Android, AVD Manager. So things built, but now I've got to go into this thing and edit it. And I'm going to take out I'm guessing it didn't like the parentheses. I'm going to finish that. It'll take a second again. All right, and I'm going to try and launch that Android virtual device. All right, let's see something. Starting the AVD, we can see down here. AVD running. Now we want to run the app. We're going to pick that AVD again, and hopefully it can fire it up this time. And maybe finally we're going to show Hello World. All that work for Hello World, right? Still getting errors. Huh. Why does it still list that type of tablet? It's still trying to run it on the wrong one. Gradle's still building. Let's see. Let's let Gradle finish. All right. It didn't want to. It still didn't want to start it. Well, let's troubleshoot some more. What did it not like about this? I'm not even sure at this point. All right, I swear I just ran it. I did the same exact thing as before and it worked. So I'm going to run it for you again and let's see what happened. Didn't change a thing. I'm going to make these windows a little bit bigger. So, Gradle build, it's saying it's launching the app. You could see the ADB command. You can actually do this command on the command line if you wanted. All right, it's actually got this thing in the background, but there's our Hello World app. All right, start with Hello World string in the front. That's all it does. That's all we're doing right now. But that's all it takes for Hello World in terms of the code we need. Again, simple Hello World, and it took us, what, 20 minutes to get this thing figured out. So again, this is why I'm asking you to spend your time getting your own Hello World up and going, and not just relying on mine, but to follow this process yourself to work through the little idiosyncrasies and the kinks of downloading all the stuff you need to do to get an application started. Don't wait until your lab to do it. All right. I'm over here in the run window. I'm going to go ahead and use my stop to kill it. All right, application terminated. In future sample code, I'll show you a little bit more about the debugger and so forth. But for right now, we have our Hello World. I want to go back and talk a little bit about the resources. And so I'm going to expand the resource directory. Realize with the resources that we're not going to, we're not doing native development, so I'm not going to spend a lot of time on this, but I want to make you aware of the resources and of the manifest and what goes on. We created an initial layout. So under the layout directory, we had this activity hello.xml. When I go to the resource directory and look at that XML file, as I said, they're described as XML files. When I double click on it, I actually get a little design editor. Let me make it a little bigger. That'll show me the set of views available in widgets, so I can actually modify it, right? So I could actually go and add a whatever we want. What kind of fun things we got? Text fields. We've got additional sub layouts we can do. If you've done GUI driven programming, we can do different things. Now, one of these on here is a web view. So since that's the one we're going to be working with, let's drag a web view on here, and it gives us different positioning. Let's see. All right. So we got a web view at the bottom here. It can different layout guidance. So here we're asking it to match its parent in terms of width and height. We can view all the properties if we want, so you can see all the properties associated with this thing, that we want to put on here. All right, so that gives us a default web view already on here. Okay. Now, the other thing I can do is, I'm in the design view, I can take a look at the text for this file. So just so you're aware, when we first created the activity, we had a default view object that was called a text view, and that's how the label text hello world got on there in the first place. All right, and we just added the web view part. All right, so we just added that part, so that'll show up, and this is what our UI looks like. The type of layout, so there are different layout types. This is called a relative layout. You saw grid layout, container layout, and so forth. The relative layout is kind of a flow layout, like in Java. And again, you kind of mess around with the different layouts you want based on a custom UI perspective that you might want to do. But we've added this automatically to our layout. So if we go and rerun the application, it will rebuild it. I'm still going to try and run on that virtual device. It's going to rebuild it. Fire it up again. There's our ADB command that we could do. A little bit more things going on during our build, but our app came up. All right. Now, it's probably very difficult to see on the screen capture, but if you could see a slight shade darker versus lighter here, we actually have an embedded web view. That web view is meant to show markup or HTML of some kind as a web view or and run JavaScript. But that's what I mean by last talk when I talked about being a Chromeless browser or a menuless browser. It's essentially a markup rendering window, but there's no menu options here. There's no status bar or anything else like that. All right, that's stuff that we'd have to add ourselves. So let's see about putting an initial web view on there. We put the web view on there. We saw it in the, let me go back to our resource file. We saw this is the view. We put that, we ran it. We saw that there's no content in it. I did add this ID field in here. So when we create a resource and we want to identify it or locate it or find an object so we can manipulate it over in the Java code, we need to identify the element. So we can use a method to look something up. So we'll keep it in our same event handler. All right, I'm going to call and now let's go and locate our web view resource. So the way you do that is we're going to create a web view object. I'm going to call it my web view. We are going to use a special inherited method called find view by ID. All right, and that ID is going to be a constant. That constant, I don't have to know the number. That constant is actually auto-generated for me, so I can actually use the r.id field, and then it'll actually look up different IDs that are available to me in my resources file. So the IDE is aware of that resources files and the constants created for those IDs. So I'm looking up the web view that we have on there. Now the only problem I have, and the reason why it's still showing red, is I've got to cast the result, right? I've got to actually say that the result coming back is of type web view. So I cast the result to a web view, and then I have a handle to my web view. Now I have a handle to an object that represents the web view. What can I do with that? All right. Well, let's load some initial hard-coded content. Now, this may not be the way you normally do it, but let's create a string with some content. Let's set that content to basically a mini web page. So I'm going to write raw HTML in here. I'm not going to put a header or anything else because I'm not putting any other stuff in there. I'm just going to go straight to the body tag and put in something like SCR421. Let's make a bold tag is awesome. Let me properly close off all my tags. And if I do this right, I have a mini web page loaded as a string. Now I've got to assign that string into my web view object. There are different load operations that you'll see. In fact, autocomplete, you can see there's load by URL, load data with a base URL, another variation of the load URL. So basically, load URL, as you might expect, is loading remote content. Load data is going to load for us explicit content that we set. So we're going to load this content string that we did. Now we have to indicate to the web view, just like we would indicate to a browser, what kind of markup it is. So I'm indicating by MIME type that it's an HTML file, and the third parameter I did not require, so I'm going to leave it there. So I just, I forgot to put the load data on it, right? So that third part was that was the encoding. We don't have any special encoding for this character content. We're going to use the defaults that are provided by the web view, and we'll be fine. So now that I loaded that data, when I run again, I'm going to save this and I'm going to rerun it. Take a minute for this guy to come up. All right, and we bring it up. SCR421 is awesome. Is awesome is in bold inside that content window. There might be times when you want to display markup and you know it and you hard code it, but more than likely you want to grab remote content somehow. So how do you grab remote content? Well, let's go back. I'm going to stop that there. And instead of, I'm going to comment, no, let me do that. I'm going to comment these two lines out, and instead we're going to go get some remote content. So my web view dot load URL. All right. And since we're getting remote content, I don't have to specify the MIME type or the encoding anymore. That's going to be determined by the web server I'm going to go hit. What web server should we go hit? How about going and hitting my web page? If you haven't seen my web page, actually before I even load it in here, let me show you what it looks like in a browser. All right, there's my web page. My web page has a responsive CSS design, but it's really just a bunch of static content. But it's a big enough page with a menu on the left that I wonder how it's going to look in that web view. I haven't done this yet, so I'll need to see. All right, let's do that. Let's run. Take a minute. Gradle, launching app. All right, client connected to the process, and bring it up. Oh, wait a minute, web page not available. The web page at that, well, we set the URL, right? All right, we got a URL, but it says error cache miss. Well, what's going on? Well, first of all, I notice how I clicked on a URL, and now it can verify that it actually sees my web page on the device. But notice, what did I just do? I just spawned a different activity. I'm now in the default browser on the device because I clicked on a URL. I'm not in my application anymore. So I'm in that activity stack, and now I have this is the responsive design part of the site, so it's a little bit different. But notice if I hit the back button here, where do I go? I go back to my application because I popped the activity stack and I'm back to my application. So I got to figure out why is it that I couldn't get to my web page from inside my web app when clearly my device has access. There's not some kind of network issue or something else going on in the emulator. Well, the answer is when we want to use a web view to load remote data, our web view is, as I said, it's Chromeless, it's menuless, but it's also basically stripped down. It does not have access to internet permissions. All right. So when you put an app on the device and it wants to use different facilities or resources provided by the container that is Android, like we talked about last time, it's got to specify as part of its manifest that it wants to use those things and that it requests permissions to use those things. Accessing your SD card, using a network connection, accessing your photos or your personal information. That's why when you install an app, you see this list of things that you have to approve as the end user, so you provide access to be able to use that information. In this case, for us to load a remote web page, we have to indicate that this app has to request that it can use an internet connection, and then the installer has to accept that. Where does that magic happen? That magic happens in our manifest. So they're talking about last time, we have 4 different types of app components, and they are specified in an Android manifest file. We're only creating an activity here, so we don't have any services, broadcast receivers, or content providers. So instead, that's why all I see declared here is my one activity, right, called hello activity. Notice it says .hello activity. Why is that? Well, here's my package name. All right, my package name is named for my package plus the name of the app, and then the name of the activity is concatenated with the hello activity on it. That's the name of my class. So basically, between this package and this Android name, I have my fully qualified Java package name for it. I'm given an intent filter. If you remember in the overview presentation, I talked about intents somewhat. Basically, the way Android knows to launch from its launcher app, the entry point into your application is your main activity is considered an intent, a request for future action. So when you tap on the icon on the landing page, that the future action is this entry point called main. So this is a special intent that Android creates to indicate, and there should be one and only one main, if you will, specified, and it should be specified under the category. So this is your implicit intent specification of launcher. How do I launch the app? I go to that particular intent. That intent is internally mapped to the hello activity. All right, and that's kind of how it all comes together, if you will. It's all this wiring that happens external to your code. All right, well, in here now we've got to figure out, and we've got to add permissions somehow to be able to use different resources of the device. In our case, we have to be able to get resources related to accessing the internet on the device. Hang on. Sorry, I got in a quick text message there I had to respond to. We have to add the ability for our application to use a resource, have permission to use a resource of the device, in this case, the network connection. You do that, we're going to ask for permission by using the uses per mission and ask for the different permission. Notice how the IDE is really helping me out with a set of available permissions. No, these are all just logical constant names that Android has predefined. Look at all the different things you can ask for, right? So we're gonna fast forward all the way down to one related to networking, in a particular internet. So there it is, Android name internet. And that's what we needed to use permission for, so I can close that tag. Notice this is not under the application, it's under the manifest, but that should be all that we need to redeploy this application and get access to the remote capabilities of the device. All right, it's installing. It's thinking, and boom. All right, it actually went and spawned an activity to go to that remote URL. All right. All right, sorry, I'm getting interrupted by some text messages. I'll stop that. I wanted to point out, I'm going to run this app for you again. And the thing I wanted to point out, and I want to put it live on the screen when it runs. So I'm going to click run. I'm going to select our virtual device and I'm going to bring it up. All right, so I'm on the welcome screen. It's going to fire up my app and boom, it starts to display my stuff, but then spawns and goes over to the web browser when it hits that load data call of that URL. Why is that? Well, remember what I specified, what was specified in the manifest file. I have this notion of an intent that's created. We talked about intents before. When I loaded the URL, meaning when I make a network request to a URL, by default, Android's going to want to use the client application most appropriate for URLs, which is by default your built-in web browser. All right. So even though you're in your own application loading the URL, it spawns another activity and says that activity, I want to use what you've always said you wanted to use for web pages, and that's a browser. I don't want to use the application I'm currently in. So it spawned that new activity and went there, which is, I can go there and I can go back, and my web view isn't there, it's just empty, right? So how do I actually tell it that I want to use? I want to use my own web view as the view to be that renders the browser web page. All right, I'm just going to cut and paste in there. You have to create a web view client, as it's called, and bind your view's web view client to be that new web view client that you create. Then when you create or when you load the data from this remote web page in, it'll actually render inside of that web view client, which is bound to your resource. Okay, so now when I run it, I'm going to bring this up so you see it. It's going to kill that version, bring back that. And now my web page shows up within my web view. It's still responsive, if you will. All right, so I'll still click on things. Now, why isn't it showing my menu like it did before? All right, now we have another. So this is all the contents there. But why is, remember when I was over, well, remember, I'll show you where was I over here. All right, I had this browser part that on a mobile device, or when I did it over in the mobile browser, I had this responsive design where this thing expanded and showed that menu that you see here. Why is that not happening here? The reason why is because that isn't just CSS. There's some JavaScript that's actually expanding that menu out. And right now, JavaScript doesn't work in my web view either. And we're going to go into this. I'm not going to show you that in this particular session. But realize when the point is when you create this chromeless, menuless, vanilla embedded browser thing called a web view, it doesn't have any of the magical capabilities of a browser by default. You actually have to go in and set things. We have to set things related to cookies. We have to enable the JavaScript. We have to enable the WebView client. So when we do a longer WebView example, we'll go through all the things that we need to set and enable. This WebView is going to have its own security model, its own sandbox separate from the default web browser on the device for that reason. All right, so I want to show you an initial hello world with loading a web page into WebView, because we are going to do WebViews, but next we're going to have to enable cookies, we're going to have to enable JavaScript, and we're going to pass information back and forth, and that's what we'll spend our time doing. So I think that's enough in terms of this session. The last thing I wanted to show you with the devices, all right, what happens when you want to actually run using an attached device as opposed to the emulator. All right, so again, I got my phone out here. All right, and you can't see it, it's off screen, but I'm going to go connect my phone into a USB port with a connector cable to a micro USB. You heard the beep. All right, installing the device driver software. It's recognizing it. All right. Not successfully installed. Don't know what's going on with that, but let's see if Android recognized it. All right. Connected devices doesn't have anything, right? Don't see your device. Let's see what Android says. Oh, it's going to send me to the emulator page. That's not going to be very helpful. So this happens all the time. All right. You have a device and you want to use it for your testing, but Android doesn't really want to recognize or anything, if you will. There's a few things you need to do. First thing is, on your device itself, you need to make sure your developer options are enabled. You have to enable USB debugging, and that can depend on the version of Android you have. So, for example, on this phone, you have to go to the About phone all the way down to the build version and tap like 7 times in a row in order to enable the developer options. And then once you do that, you go into the developer options and you have to enable USB debugging. So it's kind of a two-step process. Earlier versions of Android, that capability is at the top level, if you will, meaning that menu isn't hidden from you. It'll be under the About phone, and you'll see developer settings explicit on there. Okay, folks, if you actually notice, I have a different shirt on, got my glasses on. It's the next morning. I was getting texts yesterday, as you saw, and actually had to leave. And if you remember, I was in the middle of trying to get the app working on a device, and it wouldn't work. What I had to come in and do in the interim was actually install a driver for my phone for Android. I'm running on a Windows 7 computer. And again, it's the kind of thing you go through in your SDK tools. For example, under Android, you go to the SDK manager. You have an SDK home here. Now, if we launch the standalone SDK manager and look at all the stuff we have, down at the bottom under extras, there was this one for the Google USB driver. And normally that's sufficient. However, on Windows 7, older ones, and sometimes with particular devices, you have to go get an Android driver specific for your device. So I actually had to go to the Motorola. I have a Moto G4. I had to go to the Motorola site and download that driver for Android. They had it right there, install the driver. And then when I did so, when I go to run, let me close all this. When I go to run, now I get a choice, and there's my make sure it's on your screen. There's my Motorola under connected devices. I still have my emulators, my virtual devices, but now I have my actual device here. There's my device. I actually have to move the camera because it's stuck on there. On my USB port, I've selected that device. I'm going to click OK. Down in the lower left, there's going to be a Gradle build, or lower right, I'm sorry. And then once that build is complete, then in the lower left, you'll see under the run window all this stuff. In fact, I'll get rid of this stuff now. Now you'll see the stuff. There's the ADB push and the ADB shell. Success. And my phone just flipped. All right. The app is coming up. And there it is, right? You can see, and there's our web view with the web page in it and so forth. All right. So once it's all working, it's pretty good. I mean, why am I showing you all this? Why is this all important? Because again, as I said at the beginning, the Android toolchain to me is pretty hokey. You got to kind of understand what's going on in different parts, what version of Android you're targeting, or allowing, I should say. For us, it was API 19 to 25 without the KitKat version which was API 20. We've got to have build tool version properly. Your build tool is Gradle, so normally you want that up to date, and you have to specify in your build.gradle. So, as an example, when you get when you use the code that I'm going to provide as examples, you're going to have dependencies on a certain set of build tools. Here's the class path to the certain to the Gradle tools. Remember, Gradle has Groovy running underneath, which is really the Java virtual machines underneath. You have to have. I mean, this isn't going to work for you when you check out from Git unless you've actually installed 222. You could have a different version. Doesn't mean your different version won't work, but you're making a reference here to a specific version of Gradle, and that has to be compatible with the environment on your system. Because remember, the SDK, the Android virtual devices, the Android debugger, which is ADB that you see in the lower left there, Gradle, these are not all part of Android Studio. Android Studio provides wrappers around them to basically spawn off and run these programs. So when they don't work well, you have to go in and kind of make sure your configuration all matches. All right, it's not the ADB's fault. It's that you're trying to put together a build and run process, perhaps with incompatible levels of tools, and you got to kind of get used to where to go. Um, it's it's not the cleanest. It can take time to get an environment stable, even on your initial download of Android Studio. I bring up existing old projects and things break, and I've got to go figure out which part of these things is at fault. And I warn you again because I've spent 50 minutes here talking to you about just about Hello World and a Hello World with a web view in Android Studio, but you've got to spend the time to get your environment stable and understand how this IDE works, or else while you're working on your lab and as you go forward into your next class working with Android Studio, you'll find that the tool chain will take up way more time than you want it to. That's for sure. All right. Anyway, word of the wise. That's why I did this whole session. Moving forward, our next session we'll talk about hybrid applications.